Now, again, this is going to be question 3 on the page, and you should look at that before you see what I have to do with it. But, okay, here it is. Now, I've depicted this, the 3 boxes here. First box with balls numbered 1 through 15. Second box with tiles A through Z. The third box with rings. And of course I didn't color them, but I don't have that many colors, but we got red, orange, yellow, green, blue, indigo, violet. So we have the 7 colors. Now, we want to get the probability that we get an odd number, a consonant, and either blue, indigo, or violet. I call those blue-like, bluish type colors. So, what's the probability? Well, probability is going to be the number of ways that we can get an odd from the first, a consonant from the second, and a blue, indigo, or violet from the third ring, divided by the total number of possible choices when we choose one from each box. Okay? Well, how many ways are there to get an odd, a consonant, and a blue, indigo, violet? Well, there are 8 odd numbers here. 1, 3, 5, 7, 9, 11, 13, and 15. Okay? We know that there are 21 consonants, and there are 5 vowels, 26 letters. That leaves us 21 consonants. And there are 7 rings, but only 3 of them are the blue type, blue, indigo, or violet. So the number of ways we can get an odd, a consonant, and a blue, indigo, violet will be the product. 8 for the 8 possible odd numbered balls, 21 for the 21 tiles with consonants, and 3 for the 3 rings with the desired colors. So that's the number of ways to get the desired result. That's out of 15 times 26 times 7, 15 balls that we could have chosen, 26 letters, 7 rings. So we can divide 8 times 21 times 3 by 15 times 26 times 7. Now these numbers don't necessarily all divide out, but 3 goes into 15 5 times, 7 goes into 21 3 times, and 8 over 26 we can reduce by dividing by 2. We get 4 here, 13 here. It gives us manageable numbers over here. We can do this in our head. 4 times 3 is 12. The 5 times 13 we're left with here is 65. So that's 12 out of 65. Now 12 out of 60 would be 1/5. 12 out of 72 would be 1/6. So it's fairly midway between 1/5 and 1/6. So it's not an improbable outcome. If you did this 10 times, you would expect to get about 2 successes where you actually get the odd, the consonant, the blue, indigo, violet. Okay, there's another way of looking at this. Okay, we could also say, well, the probability of getting an odd when we reach into that first box is 8 out of 15, because there are 8 odd numbers, 15 balls. The probability of getting a consonant when we select from the second box is 21 out of 26, and that's fairly obvious. And the probability of a blue, indigo, violet out of the third, there are 3 blue, indigo, or violet out of 7, so that's 3 sevens. So the probability of an odd and a consonant and a blue, indigo, violet when we reach into each box is going to be the probability of an odd multiplied by a probability of a consonant multiplied by a probability of blue, indigo, violet, and that's going to be 8/15 times 21 over 26 times 3 over 7. Looks like I managed to smudge that 15 a little bit in moving this board around. Okay, well, if you see what these numbers are, the numerator is 8, 21, 3. 8 times 21 times 3. The denominator is 15 times 26 times 7. The numerator and denominator perfectly match the numerator and denominator we had here. So this is an alternative way of answering the same question. And we'll get more formal about the alternatives a little bit later, but just right now trying to develop a feel for the whole idea of probability.